Okay, good morning. We're going to start talking about the next topic in calculus, which is differentiation or finding derivatives. And we're going to go through a little explanation on where all this comes from. Um, if we zoom out on this graph that I'm showing right now, you would see that it's a cubic polynomial. That's every math teacher's favorite function to start with. But we're just going to focus on this piece of it right here. And you can see I've defined a point here. That point in blue is labeled as x1 f of x1. You can see our function up here. The function itself isn't really important for right now, but we are concerned with this point here. And what calculus really, one of the first topics we really deal with is in algebra, we learn how to find slope between 2 points. That's wonderful on straight lines because they have a constant slope. But most of mathematics is not straight lines, and therefore that doesn't help us a whole lot. And sometimes it's important when we have a complex equation that describes something, it's important for us to calculate what the slope is at a single point. And that is what we're going to start doing today with calculus. So we have this point here defined, x1, f of x1. And we're going to define a second point. But instead of defining it as just picking another thing and calling it x2, f of x2, we're going to define it by how far away from the first point the second point is. So I've created 2 extra points here, and we're going to talk about this one first. You can see this one is x1 plus h. H is some unknown amount. And then its y-coordinate would be f of x1 plus h. And so we're going to go ahead and turn that point on. If there's a lot of stuff going on here on the left, you don't need to pay attention to all of it. But we have a slider here that will define where our x value, our blue point, is, and we can move it. And you'll see the other point moves with it, and that's because it is locked in and associated with that first point. And what we have here is we have a slider for h that will move that point and tell you how far apart it is from one x value to the next x value. So when this point here happens to be a 3.23, and we say that the h difference is 0.24, then you would know that this point's x value is 3.47 because it is that far away from it. So we're going to go ahead and move that one out a little bit. So the next thing I've done is that in algebra, we calculate slopes between 2 points. And we know how to calculate slope. We do x or y2 minus y1 divided by x2 minus x1. And I've actually set that up here. Okay, so I have a slope formula here, a y value minus a y value. In the denominator, it would have had x plus h minus x. And so the x's would have canceled out. You've been left with nothing but h. But you can see here that this is going to put out the slope between these 2 points. Okay? Now I've defined a second point, h, x1 minus h. So minus the same amount. So it is the same distance away from the original point as the second point is. And we'll put that one up and you'll see there now. The y distance isn't the same because the curvature of this graph is different. But the distance on the x-axis from point 1 to point 2 and from point 1 to point 3, that x distance is remaining the same. Set up right here. And I also have a slope output for this point between the slope between this point to the left and this original point. Now this point is going to stay right where it is. And as we move this h value and we make it smaller, we'll see those points get closer and closer. As we move it away, those points move further and further away. There's a slope output here. And I want you to pay attention to this slope here on the right and this slope here on the left as I move this h value. So as I move, I'm going to start it all the way out here at 1. You can't even see the points. This one's at 5.2287. This one's at negative 2.15. I'm going to start moving that h value smaller, which means my 2 points are going to start getting closer and closer to the original point. Now I've cut it about in half right now. We see this one that was up above 5 is down to 2.49, and this one was at negative 2 something. Now it's only at negative 1. Keep going. 2, keep going. 2, keep going. Keep going. Keep going. Now you'll notice that my h value is locked in. The closest it can get is 0.0001. It can't actually become 0. Think about it. Look at the slope equation. What's the denominator? H. If h becomes 0, we get an undefined. Because if h becomes 0, then we're trying to find the slope at a single point. In algebra, we can't find a slope at a single point. Calculus, we can estimate what the slope would be at a single point. So let's keep moving that closer and closer and closer and closer. Now look at these two slopes. We're not even all the way there yet. We can go another thousandth. What's happening to the slopes as those points get closer to the original point? 0.53906901, 0.538333. Those slopes that started very far apart from each other have consistently gotten closer and closer and closer to the same value. In this instance, a little bit above 0.5 as a slope. So what we're doing here is we're doing an estimate. We can't calculate the slope at one point because we can't plug in 0 for h. But we can estimate what that slope at a single point would be by progressively moving these points closer and closer to our single point of interest and examining the trend in that slope output. And we can see for this x value right here, which happens to be at 3.23, as we move closer and closer to that with our other 2 points, calculating slopes between them, our slope gets closer and closer to a value of 0.539. This is exactly what finding a limit is. Remember when we first started finding a limit, we were plugging in numbers closer and closer to our x value. We can't find the slope at one point, but by using limits, we can predict what that slope at one point would be. I've also added things here to make this a little more visual. These are point slope form equations. I've defined, we have our points defined. Y minus y1 equals slope from the left, here it is, times x minus x1 minus h. So we've got a point slope form here that will find the slope between these two, or find the linear equation, define the linear equation between those two. We have a point slope form that defines the linear equation between the x value, x point, and our point to the right. And again, watch what happens to those two lines as I drag this slope, or drag this x difference smaller and smaller, and bring those points closer and closer. What happens to those lines? Eventually, they're going to overlap each other, because we hit the point now where our linear equation, our slope is practically identical, and our points are practically identical. So what we're doing here is we're using the limit concept that we learned in chapter 1. We're using that concept to predict the slope of a curved line at a single point, which is something we could not do with algebra. So that's a simple. I don't want to say simple. It's not simple, um, but that is really the basis for the first thing we're going to learn in calculus, which is finding what we call a derivative. And we're going to take some notes and do some practice problems with that today. And I'll be ready to answer questions because I'm sure we're going to have some.